Hello everyone, welcome to this tutorial. My name is Emerson Ahrari. I'm a Google Earth Engine expert. In this tutorial, I'm gonna show you how to make grid of values in the Google Earth Engine platform. So, such grid structure is very useful for spatial analysis in GIS software. As you can see here, I have a grid value of temperature variation over a study area. And here you can see the temperature differences with different color and different classes. In the left panel, here is Google Earth Engine platform. I'm gonna show you how to call satellite data and also aggregate satellite data information to each cell separately like this, and how to get exports and bring it and visualize it in GIS software. So now let me make a little change in the view. In the left panel we can continue. You will be able to use this tutorial for all around the world, not limited to a satellite data, a single satellite data, or a specific region on the world. You can use this tutorial for whole of the world, and you can use all of the satellite data for this tutorial. So, first of all, let's find your region of interest. For example, I'm gonna select Tehran as actually the city I was born. So now through the FOO administrative layer, we wanna call province borders. Go to search places and dataset and type, for example, FOO administrative layer. Different administrative layers simplified are available. The first level related to the provinces. Map.add layer allows you, just like that, to see the province borders for all around the world. I'm gonna select and separate the region including the Tehran, the capital of Iran. That's why a new variable as ROI created. From input table, filter based on a boundary. The boundary intersected with the geometry. Here it is, geometry. Sorry. Let's run a code again and visualize ROI, just like that. Now you can see the shapefile including Tehran, the province including the capital and the other cities in this region. So in the next step, I'm gonna show you how to make a grid structure for the selected region. So now make another variable as grid. Get the ROI first, ROI selected, and then throw the geometry converted to a geometry type from a feature collection converted to a geometry thanks to this function. Then covering grid is a function allows you to make a grid structure for your border. So the border area already defined by ROI. Through the map.add layer, you can visualize created grid. But sorry, it was my mistake. Covering grid included two arguments. The first projection system equals to WGS84 that should be explained by EPSG 4326. And a scale is very important. Sometimes you may want to make a grid structure with, for example, 10,000 meter size per pixel. For example, here a scale could be 10,000. Let's run a code, and after a few moments you can see the gridded structure. Let me to switch it off, the previous one, and the current layer or the the grid structure with 10,000 meter grid cell size is available here. Or you may want to reduce the size of pixels, for example 5,000 meter. So as you can see, more detailed grid structure is available. The example here created by 500 meter cell size. Remember that a smaller cell size, more detail, and vice versa. So the grid structure created. If you want to have focus on the study area, map.center object is necessary. So now the grid structure created. The next step, I'm gonna calculate or aggregate the LSD based on average value under each cell. That is very important thing. Something like zonal statistic we want to do here. So let's call the temperature data first. Temperature is an example. You can use NDVI or other products you prefer. So here I'm gonna call Moody's temperature data. Through the search places and dataset, Moody's temperature data called 8 days interval and 1 kilometer spatial resolution, imported into the code as an image collection, assigned to the Moody's variable, and then filtered based on a period of time. For example, I'm gonna actually make a grid LSD values for LSD night in 2021. So the filter date should spans our data for 2021 to 2022. Remember that if you know about the satellite data in the Google Earth engine, you may know the Moody's temperature data included couple of variables or couple of bands that you must select the target one before further analysis. Otherwise, you can get information about the products and bands through the link available here. So, this is LSD day and LSD night. Both of them are available. For example, I'm gonna have LSD day and night together. So let's copy and select the target band here. Make a bracket, LSD day and LSD night. If you back to the data properties, under band description, the other band is LSD night with 1 kilometer. And we have a scale factor 0.02 help us to turn the value to the Kelvin units. So LSD day and LSD night. The other one was LSD night data. Suggest you to reduce the length of the name. For example, day and night. So just like that. To apply the scale factors, a new loop structure created using map function. Each input image under image collection for a period of time called as IMG. So make a new variable and first make a variable as, for example, temperature. The input image should multiply to 0.02, the scale factor already pointed out. The function returning rescaled temperature as it is in Kelvin scale we need to subtract it from a constant value, 273.15. The temperature returned with the properties of input images. Property names. All properties copy and paste here. So finally, we want to get average from temperature, day and night for 2021. So let's get a print here. Print MODIS. Open the right panel. You will have one single image with two bands. One of them LSD for days, the other one LSD for night. So in the next step, we need to do some sort of zonal statistic analysis to aggregate LSD values into each cell separately. For each cell, I'm gonna get the average. So average temperature here, I mean. A new variable as stat is created. The grid structure already called as grid variable. Let's call the grid data first. Now we want to go through the all cells available here. That's why we need to make a loop structure for grid data 2. Make a map. The input for function will be feature. Each cell considered as a feature here. So now I'm gonna aggregate temperature based on mean operator for each cell. A new variable as vals created equals to, so get MODIS temperature average data first and then reduce region. The reduce region is a popular function for spatial aggregation. So couple of arguments should be considered here. The first one is a type of statistical operators. Earth engine dot reducer dot mean allows us to get the average for each pixel. The next is the geometry equals to the region of interest equals to each input feature already considered as a geometry. So, and the scale for a spatial analysis could be, for example, 1000 or 100. It should be better to set the scale based on a spatial resolution of input data. For example, the input satellite MODIS temperature, provided 1 kilometer or 1000 meter spatial resolution. So that's better to set the scale as 1000 meter. So the values extracted for each cell. Now we want to have new properties for the grid data, included the day and night average temperature for each cell. To do this, the function returns the input features as an output with a new property. We can have a new property as values or vals, just like that. The set is a useful function to add a new property here. Let's get a print from stats. In the right panel, a new feature collection creating. We are waiting for computation. As we have large number of features inside the grid structure, it is 1059 elements, so meaning that over the 1000 times the calculation, this computation should be repeated. So finally, for each cell, we have a day and a night temperature for that is related to average temperature for 2021. So, the statistical information, the target data gathered for grid structure. In the next step, I'm gonna get export and open it up into QGIS software, such as the example already shown you in the right panel. So, export dot table to drive. So, couple of arguments necessary. The first is a feature collection we want to get export. The collection equals to stats and the description, name of the output. The output shapefile could be, for example, Tehran, LSD, day and night, just like that. And the next is file format equals to SHP because I'm gonna have a shapefile as an output. You can also set a folder for the output. For example, the test is the target folder here. Let's save your code and run it again. After a few moments, under the switch to the task, you can see a shapefile is ready to save. Tehran LSD day and night. Click on run and run it again. Now we are waiting for saving process. Once the process of saving is over, completed, the tab's color turned to the blue, meaning that we can go to the Google Drive and pick up the output and open it up into the QGIS. Now I'm waiting to see the final result situation. So, if you had any problem or any issues regarding to the code or programming technique, just you can find the code link below this video on my YouTube channel and you can compare my code with yours. And if the problem still exists, you can reach me out on my YouTube channel through the comments. Less than 1 minute, the saving is done. Open in Drive and find the Tehran temperature data. For example, when I click on T, you can see the Tehran data, all of them listed here. Tehran LSC for day and night created. As it is a shapefile, we have a lot of auxiliary data that should be downloaded next to the SHP to able to open it up into GIS software. So click on download. After a few moments, the process of downloading started. Here you can see Tehran LSD is ready to download. So now the data downloaded and I'm gonna extract it here. Let's see. Tehran LSD is ready. There it is. Extract to Tehran LSD as a folder and you can see the SHP, PRJ, DBF and also the other files available here. Just drag the SHP file into QGIS. Now you can see the Tehran LSD is available here for day and night. Open the attribute table and here you can see two columns available. One of them refers to the average temperature for the night and another one about the day. So now we can do the visualization using a styling panel or using the symbology. Simplest way, go to properties and then select the symbology. Based on graduated style, you can select the target column, for example, night LSD data, and then try to declassify the values. So just like that, click on apply. In the right panel, you can see the temperature variation. I will increase, let's make it a little bigger, sorry. You can increase the number of classes using this part. Click on apply and then let's quit from symbology. I'm gonna actually make it a little bigger. That shows the temperature variation better. Again, go to the properties and here you can try with different color palettes that shows the negative and positive or different classes with a better color palettes. So let's inverse it first because I'm gonna show higher temperature with the warmer colors and lower temperature with the cooler colors. Click on apply and then click on OK. This is based on night temperature. This is same as the previous example. As you can see here, we have LSD night data here that shows the temperature variation for each pixel. Through the identify, if you select on a pixel, you can see the temperature for day and temperature for night, just like that. Such kind of output is very essential for a further spatial clustering, hotspot analysis, and other spatial analysis, spatial data analysis that is considered for the most of the studies related to the spatial science or geoscience actually. So, and you can also make such data set for your own region of interest with various attribute tables with various columns. For example, LSD day and night, precipitation, vegetation cover, and so on, and then do this geospatial analysis for your region of interest. Such grading structure also could be very helpful to make a unique grid structure for the data with different spatial resolution. Imagine that I have couple of data, one of them 1 kilometer, one of them 500 meter, one of them 10 kilometer. I can make a grid structure with 5,000 meter, smaller or higher, it's totally up to you, and then aggregate the data to see the spatial pattern in a single resolution over my region of interest, and it is also could be very variable for further geostatistical analysis. I hope you liked this tutorial as much as I did. Feel free to reach me out and please share this tutorial with others in remote sensing community. Thanks for the attention.